Dear friends, welcome to this electrical engineering knowledge sharing channel AMP Power System. We are discussing workshop 8. In this session under workshop 8, we'll be discussing about the numerical or digital protection relays, various features and its application and interface with the switchgear control, monitoring, indication, alarm, etc. system. So let us discuss this protection relay interface with the switchgear. This protection relay is very important part of the switchgear. Nowadays, this intelligent or numerical or digital protection relay, it can take the entire control. Either it is a manual or automatic, entire control, entire indications, entire monitoring system, all these things it can take care of the switchgear. That's why to discuss the various potential of this protection relay is very important. That's why we have thought that we make a separate session on this protection relay. Now this protection relay, if we look into today's protection relay, it has a different from the old protection relays. In the previous or old days, we used protection relay only for the purpose of protection of electrical circuit. That means in case of abnormal operation of the circuit, the abnormal condition is sensed by a sensor, and that sensor signal, that is a CT or PT signal, sends to the relay. Accordingly, relay will activate and it will give the tripping command of the circuit breaker to trip the breaker. In addition, there is some indications available on the relay to indicate whether relay has operated or not. That is the only features available in the old days relay. But with the evolution of the solid state devices and then digitalization of these relays to today's digital, on the digital platform, this protection relays can do the job which the old protection relay can do. In addition to that, it has a lot of different features, and those features are various ways it is interfaced or interconnected with the switchgear, and which leads or help to control indication monitoring of the switchgear. That's why we need to discuss this part. Now, this protection relays have two parts, mainly two parts. One is a software part, another is a hardware part. Now, in this session, we will not be discussing about the software part, because that will be not be right, because the software of the protection relay is decided by the various manufacturer. Each manufacturer, they have their own patent software which they use in their relays. So discuss on that software is not very helpful to us. So we will be discussing about the various features of this protection relay which are interfaced or which are used in the hardware form, or which are interfaced with the switchgear system, switchgear control and monitoring system through the hardware. That part we will be discussing. So our discussion will be limited to the hardware interface or the wiring interface, or the various potential of the potential of the protection relays, which will be interface or hardware with the switchgear various schematics. That part we will be discussing. From that point of view, if we look into the protection relays, in a brief, the protection relay has a 6 features which we generally interface with the switchgear control schematics or control system. What are the various 6 features? One is this: protection relay has a input capability. I will be discussing one by one details. The protection relay has a one input capability. One of the feature is a input capability. It can take various digital input. This is the digital input. It can take digital input. That is one of the function, one of the interface we can do. Digital, it can take digital input means the input in the potential free contact from. We can give to the relay potential free contact from the field. These inputs means these signals. All this input means input signal is coming from the field. From the field, there are various devices. Except the protection relay, all other devices are called as a field devices. From those devices, this signal is coming. This signal can be coming at the digital form as well as analog form. Digital form means it is a potential free contact is coming from the various devices in the field. Analog form means it is coming as an analog signal, either current signal or voltage signal, which is a continuous. But digital signal has a two state, either on or off, like a potential free contact. Suppose this is a potential free contact. The moment the contact is on, this is off. This is the zero state. The moment the contact is getting on, then it is called one state. So 0, 1, 1, these are the two states of the potential free contact. So this contact, this is called the digital input. Analog signal, what is the analog signal? That is the current signal, voltage signal, which is coming from the CT, PT, all these things. So we will be discussing this both digital input as well as analog input. So one of the capability of this digital relay, it can take the digital input as well as it can take the analog input. That is the second part, it can do analog input. These are the, from the input point of view, these are the two things it can take, as well as it can take number 3, another analog signal, that is the DC control supply to the relay, because this relay is a, you can say this nowadays intelligent relay is a small computer. It is another computer and it has more capability than computer. So this operate this internal system including software, it needs a control supply. So that another analog input we are giving, that is a 48 volt, 24 volt or 12 volt as per the capability of the relay. That digital DC input also we have to give, DC voltage input we have to give to the relay. That is also another point. These are the mainly 3 input we are giving to the digital relay. Then the digital relay, as it can take the potential free contact, it can give output as a potential free contact as well. That is we call digital output or binary output. The digital input we call is binary input. Those binary input, how we identify? Binary input 1, binary input 2, binary input 3, we are coming, how much it can be. Similarly, this relay can give as a digital output, as a, it can give output also as a digital. So those are the digital output is a potential free contact, as it can receive the input as a digital contact on a binary contact or binary input. Similarly, it can give the potential free contact that we have discussed. This internally there is a various small relays are there. Those relays has an output contact. That contact is actually giving as an output contact. That is another interface we can, this output contact we can use in the switchgear for various control and indication alarm in various purposes. These inputs also we can use in the various purposes. We will be seeing that one by one. Then third is this switchgear, this protection relay, not switchgear, this protection relay also another interface. What is that? This protection relay can be interfaced with the laptop. It can be interfaced with the other serial system, other printer, all these facilities there. For that there is a various port is available. You know, this laptop is connected to the various hard drive, printer, mouse, all this thing, it is connected through a port. So this protection relay also it can incorporate various ports as per the requirement. Normally most of the relays you will see there is USB port is there, that is universal port, which we can use. We can connect the laptop, we can connect the hard drive or various devices we can connect the mouse on this protection relay there. So there is a USB port is there. Sometimes some of the relay there is a one USB port on the back side of the relay, one USB port on the front side of the relay, where we can connect the laptop to look into through the laptop what is happening in the relay. Then there is a communication port or serial port, because this relay, these has a various data. You know, these data we can transfer to the remote area for the various purposes. So those data to be transferred from the relay through a cable, that is we call serial cable. The serial cable also we can connect to the serial port. So there is another port, this is serial port, we call it is a 9, this port can be 9-pin port or 25-pin port. This port we use for the serial communication or data communication, data transfer from the relay. Then this relay has a Ethernet port which we can use for connecting direct to the network. If we want to connect this relay direct to the network, communication network, we can use through the Ethernet switch. This is the Ethernet port to connect the Ethernet cable. This is, there are various, there you are also there, you can connect a parallel port if you want a parallel path data to be communicated. In that case we have to order accordingly through the parallel port. That is also we can connect parallel port has a higher communication capability, that also we can incorporate as per requirement. So various digital devices we can connect through this interface. In addition to this, most of the protection relay has a capability, nowadays numerical digital relay has a capability to connect the optical cable direct, because nowadays long distance all the signal we are communicating through the optical cable. Even the differential relay we are connecting or communicating between the two end, long distance between the two end. Suppose there is a subsea cable and the subsea cable is protected by differential protection, the protection signal is going through a fiber cable which is going through the subsea cable. So the fiber cable connection facility also available with the relay, that is we call the optical port. That is a electrical signal is converted to optical, and that is going, and on the reverse way from the remote end optical signal is coming and that is converted to electrical signal which is going inside the relay. So optical signal is, the optical cable is connected over here, it is giving a electrical signal, or rather other way, electrical signal is giving to the port and this optical signal it can go. So there is optoelectrical port is also available with the relay. These are the then, and finally there is another interface facility with this relay. That we have already said that protection relay, this is itself a big device, intelligent device. But if this device itself failed, then what will happen? We will not get all the all these features, all this interface, nothing will work. So we do continuously, not only hardware, even the software. If the software failed, then also we will not able to use this device. We cannot use its potential to the which are already interfaced with the switchgear. Then all the control interlock will not work out. To avoid to monitor, for that purpose this relay need to be monitored continuously. For continually monitoring this relay, there is a watchdog system. The moment watchdog system, till the watchdog system is working continuously, it give a green indication. But the moment the watchdog system operate, that means when the relay failed, immediately watchdog system operate, and then it give a changeover contact, and that changeover contact will give a either red color indication or alarm to the remote that the relay has failed. That system I have shown the output contact only, changeover contact, that is a NC contact, this is NO and this is the common, this is a watchdog system output. That is also another feature of this protection relay which we can interface with the switchgear. So these are the brief of the various features available with the switchgear. So what we discussed? Input, we have the analog input, we have the digital input, we have the digital output or binary output you can say, then we have the computer or hardware or the various digital devices interface facility, we have the optoelectrical interface facility, we have a DC power supply facility, then we have a watchdog facility. These are the seven system, hardware system available with the protection relay which we can interface with the switchgear control system to get a better control, indication, alarm, etc. In addition to this protection relay also has a lot of indication lamp, a small LED on this protection relay. There may be 12 or 18 indication lamp we can order accordingly. It is very small LEDs that is also mounted on the relay, and this each LED we can configure for a specific purpose, protection function, control supply availability. Even the watchdog relay failed, in that case it will not work out because control supply, if the control supply is not available, then if the control supply available and the watchdog failed, we can also configure the output indication lamps. So that is another feature available with the protection relay which we can interface with the switchgear. So these are the various features. Now today in this session specifically we will be discussing about the input facilities of the input or binary input and analog input interface with the switchgear control system. Now analog input, we have already said this protection relay vital requirement is the analog input. That means the protection relay main purpose. If we look into the protection relay protection function, then the analog input is very important. But when you look into the protection relay control function, control and interlock function, then the digital input and digital output is important. So protection relay, as we are telling protection relay, main function of the relay to protect the circuit, that is protection function. When we are going to the protection function, then the most important part is analog part, analog input part. How that analog input part? I am deleting this part from here. This analog input part, how it is made? the analog input is coming from where? From the CT and PT in the field. So this, if you see the digital relay on the base, you can see there is a analog input termination features available. There is a terminal. Suppose there is a VT terminal. There is a 4 winding. Suppose this is a VT. Suppose this is a VT, and then it is neutral. So you can see here, this is inside the VT. Suppose you are giving here 120 volt VT supply or 110 volt VT supply here. So this internally, this 110 volt it cannot take. So the potentially inside there is a winding arrangement which will reduce the input voltage to the required level. So these terminals, these are the input voltage, analog input we are giving to the relay. Then similarly you have a CT. Suppose there is a 3-phase CT we are connecting over here. CT signal is coming from the field. Okay, CT signal is coming from the field, but that signal is a 1 ampere or 5 ampere. But internally that signal 1 ampere or 5 ampere CT signal further reduced to make fit for the protection relay. So though there is another winding inside the relay, you can say another way. So where this is the CT output input. So we are connecting the CT input here from the field. That is maybe 1 ampere or 5 ampere. But when we are giving to 1, then this internal winding will be reducing this signal suitable for this protection relay. So these are the analog input, CT input. Similarly, there is earth fault CT maybe. So for that there will be another winding over here which will take the earth fault signal. Suppose this is taking earth fault signal from the field, that is maybe 1 ampere or 5 ampere. We can select the input, we can configure the relay is whether it should work on 1 ampere or 5 ampere. When we will be configuring the relay, we will be using the relay software where we can include these ratios and all these things. So these are the analog input. That means analog input to the protection relay is what is that? Voltage input. That means it is either it could be VT voltage. If it is a generator protection relay, then it has a 2 volt input. One is a line PT, another is a bus PT. Both, then there will be another winding over here. Suppose this is a line PT. Okay, and then there will be a bus PT supply will be also coming over in the relay. If this relay used for the generator protection. So then there will be 2 analog input. One analog input for the VT, from the VT supply point of view. There are 2 analog input. One is a bus PT supply, another is a line PT supply. Similarly, in the differential relay, this CT input could be multiple type. There will be maybe 2 core we are using, 1 core for the earth fault, overcurrent, etc. Another core we are using for the differential. In that case, there will be another CT input like this. So these are the analog input for the CT, which will be used in the relay solely for the protection purpose only. But this is the analog input. So similarly, this digital relay has a various analog but digital input we can provide. Those digital inputs we call as a binary input. As I said, this binary input means it is a potential free contact coming from the field. What are the potential contact? How we connect? Suppose binary input 1. Suppose it is one of the binary input. What are the main signal we use to or we provide to the protection relay to make it complete or to interface with the control indication alarm system or control system of the switchgear? Mainly various power devices status. What are the various power devices? We have a circuit breaker, we have a disconnector, we have a earth switch. All these devices status, whether the circuit breaker on or off, disconnector is on or off, earth switch is off or earth. All these status we give to the protection relay to interface or make interlock with the other system. So when we make, in old days, we make the interlock by wiring the contact from one device to other device, and then we wire up that contact and then we make the necessary interlock. But in the digital relay, we do not make that complex wiring. We configure, but we make a logic because the software inside the relay can accept the logic. We make with this various status of the power device, we make the logic, and that logic work as a interlock. Okay, but to make that logic, we need this input. The which logic? Suppose I want to make sure before closing the circuit breaker, I want to make sure that earth switch is not on or earth switch is not closed and breaker is in service position. Okay, that is I want to make sure. So what we will do, in the old days we used to take a breaker on breaker service position contact. Then we use that earth switch not off, means earth switch is not off, not on. Suppose this is earth switch is open. Earth switch open means that earth switch open for NC contact, and this is a disconnector is on. The moment disconnect it will close. Then it will give a permissive, means there may be on auxiliary relay will be using, that auxiliary relay contact will be using as interlock. This way the multiple signal we can use it. Suppose this is a disconnector is on, earth switch is open, earth switch not closed, and then lockout relay not operated. So we can 86 lockout relay contact, NC contact not operated. If all this condition is met, then only what will happen? The auxiliary will pick up this auxiliary relay contact will be using for in the breaker closing scheme. We make that interlock in old days, but nowadays all this interlock I can make inside the relay by configuration or by logic. So this logic, how, but to get that, to make this logic inside the relay need to know. So this is the condition to be sensed by the relay. So all this condition is to be we have to bring to the relay. So that's why if the breaker status, disconnector status, earth switch status, lockout relay status, if we bring inside the relay, then we can make the relay whether that is on. If we bring on, then when this is not on means it is off, like a gate, logic gate, or gate or NOR gate. If it is if this binary input high, that is on state. If the binary input high, not high, then it is off state. In this way, this binary input we can use in the digital relay, in the switchgear control system. Now, what are the various status normally we bring? Nowadays, this relay can be ordered up to 48 or more than 48 input. If we order a relay, that relay should have capability of 48 input receiving. It can receive, they will give the relay with a 48 input contact it can take. So now suppose binary input 1, we assign that is a breaker is open. Okay, breaker is open. So breaker is not closed. It is a 52A contact we connect over here. So the moment 52A means breaker, this is one of the yellow contact or breaker status contact. Then this contact I can give breaker NC contact. So this is a 52B contact. I give to the input. So as we need the relay, as the signal we need to configure the relay, whatever the signal I need, I can use from this. When the moment binary input 1 is high means this contact is closed, means we will understand breaker is closed. The moment B2 binary input 2 is high means this is a NC contact. So the binary input high means breaker is open. The moment this contact get open, then binary input 2 will be low. It is 0 status open. So it will understand reverse logic. So once I give this one contact, then I can make the other one. So this is supposed to 2 input of the breaker. Similarly, we can give the disconnect. Our binary input 3. I can give a status of isolator status. Isolator is off. Then binary 4 we can give isolator is, suppose isolator is closed. So this way various inputs. Suppose here I am giving another input. This is one of the, suppose it is lockout not operated. But lockout, it is a lockout in healthy. Lockout not operated status I gave over here. Then I can give what that was the bus bar differential not operated. So bus bar differential not operated. This is a 87BA. Bus bar differential not operated. That contact I can give. When we are operating the circuit breaker or switchgear, the operation can be done from the local remote. I can give the local remote switch over here. Suppose I want to assign binary input 47 for the local position. So what I'll do? I'll connect the local position contact. It is a local position that we have seen, the local remote selector switch. The local remote selector switch, local position will connect over here. Suppose remote position will connect over here. Okay, 48. Binary input 48 is connected for the remote position. So we can connect over here. In this way, suppose there is emergency push button you operating. Suppose from somewhere emergency push button has been operated. The moment emergency push button operated, in that case what will happen? The protection relay need to know that emergency push button operated, so it will remain idle. So protection, that input, that emergency push button contact, I have to wire up to the protection relay. Suppose this is the binary input 10. This binary input 10 I wired up for the protection relay. So what I'll do? I'll put this is my binary input 10. Suppose VI 10. In the 10, what I'll do? I'll connect this emergency push button. That will indicate that my emergency push button has operated. So these way various input I can configure as per the requirement. Similarly, suppose I have another input. Suppose I have another input over here. Suppose this input I am looking for this. Suppose there is a synchronization switch. That synchronization switch can be auto position, manual position. Suppose I want to that operation, that logic, that status also to be given to the relay. So what I'll do, I'll put synchronous switch in auto position. So it will be sync in auto. So the moment I put the sync switch in auto position, relay will understand synchronization has been put in auto position. Similarly, the moment I put it in manual position, this contact I can give this in, suppose binary input, this is a BI 15. Suppose this is a BI 16. So that is also I can connect in this way. In this way, various input, various status from the field, all from the field, it is coming to the relay. Suppose the transformer. Suppose there is a problem with the transformer. So what I do, here I want to bring the transformer abnormal status to the, I can give a contact from the transformer, overall protection was operated, or maybe protection there is a trouble with the transformer. So I will give one transformer travel signal over here. That will show that transformer is in trouble. So that is also input is there. All the input will be recorded, and this input, now this input I will be using. How I will be using it? I will be using to configure the relay. How is that? Suppose I want to, suppose this image is, or suppose there is a somebody want to this suppose this relay need to issue a tripping command from where? From in the case of, suppose there is a transformer trouble. Suppose what I said, this is a transformer trouble. So when the transformer got trouble, suppose we want to trip the breaker. So the moment this will get, this is the transformer trouble, okay, or transformer fault. If we program or if we configure the relay, in case of transformer trip, the relay should trip. So what we'll do, the moment this binary input 12 is high, then we can configure when it is high. That means when it is 1. When this binary input BI 12 equals to 1, then I can say, okay, I have an output relay by 21. It will become 1, and this binary output 1 I will connect to the trip circuit. Then immediately the moment binary input 12 is high 1, immediately binary output 21 will become high, and it will connect to the trip circuit and it will trip. So this way, these various input we can connect in the switchgear control schematics. How it will be actual schematics, how it will look into. We can draw some drawing for that. How it will be. Suppose this is a 24 volt DC. Suppose this is a 24 volt DC. Okay. Now suppose breaker 1 status I am giving. How I will give? This is a breaker 52A contact. It will connect to the binary input 1. Suppose BI. I will show in this way. What is this? This is a breaker 1. CB1 status. It will give CB1 status. Similarly, I can give 52B contact over here. That is suppose binary 1. There suppose this is your binary input 2. It will become, it is a 24 volt DC. Okay, 24 volt DC, because this binary input it is equal 24 volt DC or 48 volt DC as per your order. So it is a BI2. It will go to binary. Suppose I want to give another input 86. 86 not operated. Okay, so 86 operated. If I want to give the logic 86 operated, then this is 86, and the moment it is operated, it will be 1. So it will get, suppose it is a binary input 3. So this is a digital input. So similarly, we can continue this way. These are all, this contact is in the switchgear devices, and this is in the relay. So this is a terminal over here. These all are terminals. This is inside a relay input card. So what will happen from this field, from the breaker, this contact will be wired up over here. Okay. Similarly, suppose I want to imagine the push button operated. Okay. So this is the imagine the push button NC contact. Imagine the push button operated. Then I will energize on of the input. So it will, the moment imagine the push button operated, immediately this input will be high, and relay will understand the imagine the push button is operated. In the way, whatever the input you want to put to configure the relay, whatever the input you need, and if that input is available in the field, you can bring through the contact, you can bring through the wiring in the switchgear terminal block. From the terminal block, you can wire up to the relay. This way, various input we can use in the protection relay to configure the relay. And similarly, the protection function analog signal also we can interface. So these are the analog input and digital input. or binary input interface with the switchgear. So we will be closing this session with this. Next session we will be discussing the how the output or binary output contact or output relays are used in the control schematics along with other various interface and indication lamps that we will be covering in our next session. Okay. So with this I am closing today's session. This input function of the protection relays or input interface or binary input and analog input interface with the protection relays. This will be clear. Hope this input binary and digital input or binary input and analog input session is useful to you, and please go through this, and thank you very much indeed. Thank you.